Assalamualaikum warahmatullahi wabarakatuh, and good day for everyone. So this is chapter 3, introduction to slope stability and landslide, part of geotechnics 1, okay, the last chapter in geotechnics 1. So I am Dr. Siti Norakuda, and here you can see a few figures regarding catastrophic event, the landslide. As you can see here, we can see the first figure, case study of Tanjung Muga. Okay. And this one is from China, giant landslide due to the hydropower project. So I believe due to the increment and decrement of water levels, so induce the landslide. And you can also click to this 3 available video in my slide about landslide in Sabah, okay, near your hometown, Taiwan. This is a very interesting video because we not only see 200 ton of rock that fall to the roadside, but also we have another rock that might be fall any time. And the last one is simulation on dam reservoir when we have a landslide. So the reservoir landslide can induce, I could say, a tsunami in the reservoir. So that's the catastrophic event when we fail to design a very stable slope or fail to monitor natural slope stability correctly. So that's the important things that we need to understand first before we proceed into this chapter. Okay? Alright, this is the outline of the chapter. The most of part 1, I would say part 1 is from introduction up to the landslide monitoring. The part 2 is all about methods of analysis, and this part will be discussed a lot, and you need to understand how to use linear method and also slip surface non-linear method in order to check for the slope stability. Okay. Alright, so slope instability will induce and lead to slope failure, as we discussed in the first slide. So if you can recall, okay, the slope stability is very related to the shear strength, of the soil. So tau, shear strength from the soil mechanics. Last chapter in soil mechanics, tau versus normal stress. We'll get the cohesion parameter of soil and also internal friction angle, another parameter of soil. And those two main parameters is very important in the shear strength. And the shear strength is the resisting force that make the slope become stable. While the failed soil usually induced by the driving force, which can be induced due to the heavily rainfall or wrong design in the slope angle and so on. And unstable slope usually can be measured by calculating the factor of safety. So the driving force shouldn't be more bigger than the resisting force, shear strength. So shear strength should be bigger. If it is small, so it less than 1, so the soil might be fair. However, you can see also in the normal or natural slope, we can have a factor of safety equal to 1, and it's still stable. Sometimes less than 1, but it's still stable. But it is a natural slope. But for man-made slope, The factor of safety should be high. Shouldn't be 1. Should be 1.2, 1.5, 2. Or in the dam, the slope for the dam being built by earth core. So it should be higher. So the factor of safety should be higher. Okay, so this is the factor of slope failure, some of the factor. It could be due to the gravity, properties of the slope, excess of water, especially rain, heavy rainfall, human factor, faulty in the design, vibration, can come from the earthquake, blasting or construction, and of course external loading, excessive external loading that couldn't bear by the slope. Alright, for the gravity, so when we have let's say a loading, so we assume this one as the slope area that wants to slide down. Okay, wants to slide down. So the shear force is usually resisted by the shear strength. So if the angle of slope more than 45 degree, usually the resisting force, the normal force become lesser than shear force that induce wants to slide. So it acts to pull the object downhill, and the opposite if we have angle of friction of the slope, angle of the slope less than 45 degrees. So what it means, if we consider the gravity factor, any slope that we want to design, any man-made slope that we want to design, shouldn't be more than 45 degrees, especially slope of earth. If we have a slope of rock, it might be stable. Next, the properties of the slope. Of course, two important parameters, as we discussed the shear strength just now, cohesion and friction. So these two parameter is very important. I could use my pen. So cohesion, the symbol is C, and the unit usually kilopascal or kilonewton per meter square. Friction can be friction of the solid particle, and can also be represented by angle of friction. Okay? And the angle is in the degree. Okay. Next factor is excess of water. So you can see the effect of water can induce score, reservoir stress reduce when we have a higher level of water, and also in the condition of a dam, when we have a rapid draw down, of water, when so we might have an excess of pore water pressure here, so the strength will reduce, so it might induce slope failure. And we can also have seepage. Water wants to seep into the ground, into the embankment, so it might jeopardize the original condition of the slope. And of course, heavy rainfall induced in the crack, so the crack will reduce the strength. Here we might induce a slope failure, and overloading at the crest of the slope. So we need to consider all these factors during our design calculation. Alright, now let's see the types of failure. So we can have different types: planar, wedges, okay, rock topper, rock fall. Usually in the soil, it is gradually, so it can have a multiple rotation like this one. Single rotation, mud flow, or sometimes also called a debris flow. Okay? Debris flow, and block slide. And it can be falls, slides, flows, or creep, very slow movement. Okay? And falls is the fast rate of slope failure, so it can tumble or free fall without any warning. So very dangerous. Okay, whereas for slides, transitional, it is usually occur when we have a planar of failure in rock, and we can have like this one in the California slum. It occurs 2 times in 1995 and 2005. One is due to the heavy rainfall, but occurs 1 month after the event. And in 2005, it occurred about a day after the heavy rainfall. So it induced a rotational slump. And a flow when the material mix and move in the fluid. So like water, but not as a unit. Like water as a together with the nature. So sometimes we doesn't realize about this one until it move in a lot of weight. And creep. So the creep have a very slow movement. It is slow but surely happen. So when we start to saw or seeing any tilting of the building or of the things, so that was the sign of the failure, of the slope failure. And this is the rate of the flow from the very slow to the very fast. And, alright, so landslide mechanism is very similar most of the time. So first, it's rise, it's water table. We can have a rising in water table. So rising the pressure. So when the water table is rise and the water pressure is rise, the effective stress is reduced. Okay, what happened is the effective stress is reduced. So that's why when we design the retaining wall to support the slope, we need to consider drainage, because drainage will avoid the rising of water table and rising the water pressure. Next, the toe removal could occur, showing that there is very lacking in shear resistance and head of loading, and also when we have a vibration, it will ultimately induce the slope failure. Alright, so this is example of poor drainage. So it should be installed carefully. Right? Make a good toe drainage so that we can ensure the water is passing, not retained at the place. And next is the landslip stabilization in soil. Okay? So we look in the soil. So make sure we try to modify the slope to make a gradient is low, not very high, not more than 45 degrees. Control the river bank erosion if we needed. Do some original, do checking so we can avoid the failure. So improve the drain, support, introduce the support if we could. So in the rock, we can do a lot of things. Rock trap ditches, gabion walls, rock catch neck, shelter, and so on. So this is another representation of the landslip stabilization. You can see rock box, gabion, rock anchor, of course drainage, geotextile also. So there is a lot of figures you can see by yourself. So I think I stop here. Okay. You can also see the landslip monitoring. Okay, I think I stop here. So until we meet again in the next video, method of analysis for the slope stability. So thank you very much. Assalamualaikum and good day.